All right, so a sphere is a solid in which each point is equidistant from the center. So our center, we start with a point. Okay, we're talking three-dimensional here now. And we're given a length called the radius. And now because it's three-dimensional, we can move that radius any direction. North, south, east, west, and everything in between. And we create this spherical shape, right? So, and we see these all over, okay? You play any sport, you probably work with a sphere, okay? Baseball, tennis ball, golf ball, basketball, okay? Not football would not be a sphere, but a lot of the sports use spheres, right? This has a diameter. The diameter goes through the center of our sphere and reaches the two sides or the two surfaces, I guess. And if we draw a circle in our sphere along the surface from the center, okay, we call that the great circle. Opposed to, like, if I start at the top of my sphere, I could draw another circle around just the top part here. That's a small circle, but the radius of that smaller circle is not the radius of the sphere. So any circle that has the radius of our sphere is what we call the great circle. And it doesn't have to be horizontal. You can go this way, diagonally or anything like that. But it has to have the same radius as the radius of our sphere. If you slice a sphere in half, we call that half of a sphere or a hemisphere. And so let's take a look at how to solve this. Our formula for a sphere is 4/3 pi r cubed. I'm not going to derive this one for you, but when you guys get to calculus, this is one of the things that you can derive using some integrals and those kinds of things. But we're going to work with that formula. It's one you want to know and memorize, and it's probably the one you're least familiar with. It's got a fraction in it, 4/3 pi r cubed, and start putting that to memory. So go ahead and find number 1, but I want the exact answer, okay? I don't want a decimal. I want the exact answer, so leave it in terms of pi, leave it as a fraction. So plugging this into our formula, our volume is 4/3 pi times our radius, 7 cubed. And if we're going to keep this in exact form, we're going to have to think of each of these maybe as a fraction. So this would be pi over 1. This would be 7 cubed over 1 maybe. And so for our numerator, we're going to multiply the 7 cubed, right? Or 7 times 7 times 7 times 4. We're not going to multiply it with pi. We're going to leave the pi alone. So we're going to multiply these 3 pieces together and then divide it by 3 times 1 times 1, which is 3. And so when you multiply 7 times 7 times 7 times 4, what do we come up with? 1,372 pi over 3. And then look at the units. We're looking at inches, so cubic inches. That would be an exact answer. Okay. Let's now, I'm going to modify these a little bit for you. So let's look at 5. And instead of saying we have a radius of 5 kilometers, I'm going to say that the circumference of the great circle is, let's say 64. Okay. So I want you to find the volume of this in exact form. So again with fractions or radicals or in terms of pi, knowing that the circumference of that great circle is 64 and we'll say kilometers, one-dimensional, sorry, just 64 kilometers. Okay, so how do we start? What do we need to find first? The what? Radius. And so you got to get these formulas in mind, make sure you're using the right one. So 64 right now is equal to what? 2 pi r. And so we could divide that by 2. Actually, we could divide by 2 pi and get r is equal to 64 divided by 2 pi. We can reduce that to r is 32 over pi. Now that we have our radius, that's as much as you can do with the radius without a calculator. That would be the exact form that we wanted in. So our formula, well, this isn't a full sphere, right? This is a hemisphere, and that's just half of a sphere. So I'm going to take half of the full sphere, half of 4/3, pi r cubed. So 32 over pi cubed. So I'm going to make all my pieces a fraction, okay? And 32 over pi cubed means, so here's what we get. We got 1/2 times 4/3 times pi over 1 times 32 over pi times another 32 over pi times another 32 over pi. Right? That's what it means to cube something. So our numerator, well, let's see if we can reduce anything. I can cancel out this pi here and this pi here. I could cancel out the 2 here and reduce the 4 to a 2. And I think that's it, right? So now my final answer, I'm going to have to multiply for the numerator, all my numerators together. So 2 times 32 times 32 times 32. Need your help with the calculator on that one. What do we get? 65536. Okay. And then for the denominator, I can handle that one. I got 3, and we got pi times pi, which is pi squared. All right, so on 5, guys, if you wanted to see that final answer, you should have 65,536 over 3 pi squared, and that would be kilometers cubed. Are there any questions on 5? Lena? 3 pi squared. I'm multiplying the denominators of these fractions that are left over. So 3 times 1 is 3, and then pi times pi is pi squared. Because I've canceled the other pi's out. Okay. All right, so we are working now on number 9 here. The volume of a sphere with a great circle area of, and I said to change this to 100 square inches. And so when we're starting on this one, we have to first find what? Radius. And so what formula are we using? Pi r squared is 100. And so when you're solving for r here, what do you do first? Divide by pi. So r squared is 100 over pi. And then you take the square root of this thing. So r is going to be positive. You know, sometimes when you take a square root, it could be plus or minus, but here we know it's positive because it's a radius. We know the square root of 100 is 10. We do not know the square root of pi, so we're going to leave it square root of pi. Oops, not 10. I said it, but I didn't write it. Square root of pi. Right? Now, yes. What's that? Well, you square root them both. So what happens here? So I'll do this. You can do this. Is that what you mean? Oh, take the square root of both sides? You could. If you take the square root of both sides, though, you still got to take the square root of pi. So you can't get around taking the square root of pi. So we all need to end up here. The radius is 10 over the square root of pi. Then it's not a final answer. If this was asking for the radius, we would have to rationalize our denominator. We can't leave the denominator, well, pi is irrational already, but we've been using the idea of let's not have a square root end in the denominator. Well, let's keep that habit, okay? So we'd multiply top and bottom by square root of pi. Now let's do that now. And so we get the radius is 10 square root of pi over pi. Question? Okay. So now let's plug this into our formula. Our volume for the sphere is 4/3 times pi times our radius cubed. So 10 square root pi over pi to the third power. Okay. And if I expand this in terms of fractions, so in the top part of the fraction, we're going to have a 4. We're cubing the 10 root pi, so I'm going to have 3 tens, which is 1,000. We have 3 square root of pi's, and we have a pi, right? So that's everything that would be in the numerator. In the denominator, we have a 3 times 1 times, and we get 3 pi's multiplied together, okay? And so we want to try to reduce as much as we can. What is square root of pi times square root of pi? That's pi. So I'm going to cancel out. So this pi with this one, these two is pi, are pi, and this is pi. And so it looks like we end up with 4,000 square root of pi over 3 pi. And we're looking at square inches. Well, we're working with inches, so cubic inches. Okay. So again, we're working at getting the exact answer, which could be square roots, fractions, terms of pi. Okay. It makes it a little harder, I know, but we need to practice that. Last one I want you guys to work on is number 11. And again, exact answer. Okay, so first thing you want to notice is we have two separate pieces that we got to find two separate volumes, right? We have, what two shapes are present here? A cylinder, and we'll call that shape number 1. And what's the other shape? A hemisphere. We'll call that shape number 2. Okay. So let's go for the volume of the cylinder. So shape number 1. How do I find the volume of that cylinder? What do I need to know? Radius. What's the radius going to be? 11. How do we know it's 11? Diameter up here at the top is 22, so radius is 11. So r is 11. And what else do we need to know? The height, which is this length right here, and that's not directly given to us. So we got to figure out what the height is. Anybody find the height? What'd you get? Huh? That's 11. How do you get 11? Radius, so if we had the full sphere in here, I don't think it'd go down to the bottom. It'd be kind of stuck in this tube here, right? Oh, okay, so this up here is 11. Is that what you're saying? That's true. Because from the center of that sphere to the top is also 11. And so you went 45 minus 11 and got what? 34. Okay, so now we got a height of 34. So our volume for this piece, for number 1, is going to be the area of the base, so pi r squared, times the height of 34. And so we need to multiply 11 times 11 times 34. Don't multiply it with the pi, just multiply those together. And what do we end up with? Something times pi. 2662 pi. We're just doing figure number 1, which is the... Oh, we got it wrong? Okay. So what is 34 times 121? 4,114 pi. And cubic feet. All right, so for number 2, the hemisphere, it's half of a sphere, so 1/2 of 4/3 pi, let me put it as a fraction, r cubed. So our r is 11, so 11 over 1 cubed. Okay? And so here we have to multiply together. Well, we got 4 times 11 times 11 times 11 times pi over 6, or 2 times 3. I'm going to reduce this a little bit. And so we end up getting 2 times 11 times 11 times 11. What is that? All over 3, right? And so our total volume now is the sum of those two volumes. So we have 4114 pi plus 2662 pi over 3. And if I want to add those together, I need a common denominator. So this is over 1. I'm going to have to multiply the top and the bottom of this first fraction by 3. What's 4114 times 3? 12,342. 12342 pi over 3 plus 2662 pi over 3. And now we can add numerators. So what's 12342 plus 2662? 15. Right. And cubic feet. All right.